Hi, my name is Jayden, Jayden.
My name is Emily, Emily. My name is Taliah, Taliah.
How can the NeuroMaker hand be used to serve the community? In order to provide equal opportunity for the deaf and hard of hearing within our communities, it is necessary to provide the resources needed to make communication easier. A couple of the most popular methods of communication are hearing aids and American Sign Language, or ASL. However, these methods come with a downside. Hearing aids are a high-cost expense and have minimal insurance coverage. ASL interpreters and users are at a lack, and many hearing people are unable or unwilling to learn. However, the NeuroMaker hand provides a solution to the lacking number of ASL interpreters. The amount of U.S. citizens that are hard of hearing is highly disproportionate to the amount of ASL users and certified interpreters. According to the Communication Service for the Deaf, there were approximately 1 million ASL users in 2019. The Survey of Income and Program Participation reported 10 million hard of hearing U.S. citizens, and the Registry of Interpreters for the Deaf reported 15,527 total interpreter certifications held. How would the NeuroMaker hand solve this issue? The first step of the process is to convert speech to text utilizing resources that can be found online. This text is then taken to step 2, where it serves as input for our program. The program matches the words in the text input to the ASL motion to be signed by the hand. Every solution comes with limitations, and the constraints that come with our solution is that ASL requires more than just the movement of one hand. Many of the motions incorporate facial expressions and body language in order for a message to make sense. They also require joint movements of the wrist and the fingers. For example, the letter R in the alphabet crosses the pointer and middle fingers. Finally, the usage of two hands and your body is needed for a large amount of the vocabulary. It would take a significant amount of resources to help with the issue of the lack of body and facial expressions. However, using a 3D printer and the resources we do have, a design was created that would imitate wrist movement. The idea of the design is that it would fit between the base and the palm of the hand. The tendon strings would go through and connect to the motors to remain functional, and the hand would slide along the arc of the wrist. The stoppers along the top and bottom of the design would also have a sensor added to prevent the wrist from sliding too far. The first design was too wide, and we determined that the hole for the shaft where the motor would connect was placed in the wrong position. It would need to be the same distance from every point on the arc. We also decided that the tendon strings would be much more effective if they went through the top of the top stopper and through the bottom of the joint. Our second design had stoppers too thin, and the placement of the hole for the shaft would intersect with the holes for the tendon strings. The design also had stoppers too thin for the touch sensor and the tendon strings. The overall size remained too wide. Our third design was the best width and length of the three prototypes and could be placed above the base of the hand. The stoppers were also a much more fitting size for both the sensor and the tendon strings. However, the hole for the shaft would still intersect slightly with the predicted placement of the tendon strings. Our fourth and final design had the same length and width as the third design, with a shortened height to make the arc smoother. The holes for the tendon strings had space where it wouldn't intersect with the placement of the hole for the shaft. The stoppers were also a size that would fit the stopping sensor. Our final solution using the NeuroMaker hand that would aid in the lack of ASL interpreters included the hand with a 3D printed wrist design that would provide us with a greater variety of words. The hand would be able to be used as a speech interpreter or even as a learning device. The overall design would increase the resources needed to provide equal opportunity for the deaf and hard of hearing within our communities.